Who am I? Just a little background. Chief Technical Officer, you will see some of that play into this talk. My job is to make sure that the stuff we do is valid and can be supported even now, but in the future, which is interesting considering AI. Chief Archaeologist. My day job, I am the software lead on the MASC-F program, which is an MDA project working with Lockheed Martin. So that's my day job. Chief Instigator, yeah, that's me. So I've been working with AI since around 2005, starting off in NLP, things like that, looking at how to build a recommendation system so that if you entered a question for a news group, we could figure out which news group would be the best place to get an answer. And then, like many in this room, I've been struggling for a while trying to figure out how do you keep up with AI. Hence the name of the talk, which is Continuous Learning for Humans. And then finally, you got to admit that the learning never, ever, ever stops. So, from Huntsville AI perspective, we started in 2018, mostly as part of a group called Co-working Night. I'm not sure who here has actually been involved in that, but it was a lot of fun while it ran its course. One of our first actual events was in this room helping the NASA Space Apps Challenge. A group of high school kids, you know, and other groups of adults and college kids as well, but most of my focus was on helping groups of high school kids learn how to set up a web server, how to access the NASA, data sources, things like that. At the time, we were more focused on the data science aspect of it. So we found that there is a group of people, or sets of people, spread throughout the community, typically working on a project where they may be the only person in their program, at their company even, that knows anything about AI. And as everything was starting to explode, it got really difficult to figure out, especially in this town where a lot of times you're working on something that you can't talk about. So part of this was creating a safe place to have vague conversations about problems that you might be running into. And then figure out how do I map that across to something that's maybe in the commercial world, or maybe a paper just dropped that somebody found out about. That's been kind of what's been driving this. We currently meet every other week over at Hudson Alpha, so you're welcome to join us. It's free to anybody that wants to participate. Given the last the bullet point, that our vision is a group of individuals and organizations in the Metro Huntsville area who collaboratively advance the knowledge and application of artificial intelligence in ways that make it available to everyone to improve our quality of life. So a lot of what we do, this is actually odd for me to be like presenting slides. Mostly what we're working through is Jupyter Notebooks or Google Colab, things that you can actually get your hands on as we're going through. If you happen to find us on GitHub, at HSV-AI on GitHub, all of the presentations that we've done since 2018 are posted there for everybody to, walk through. So if you can't make it, that's kind of been our approach. Again, the trying to make it available for anyone that wants to play. I think that's been one of the key forces actually driving AI adoption overall. The way I tried to explain it the other day is I used to drive a Jeep. A Jeep Wrangler, all that kind of stuff. I would get magazines of all the new parts I could add on, or hey, you could get these doors or this top, or it's plug and play, replaceable. You don't find that with other types of vehicles because a lot of things are proprietary, or they're closed, or they're, you have to get it from this vendor or whatnot. So that's part of what we think makes AI so approachable and why it's gotten so wide adoption, but that's also why we do it the way we do it, because we want to continue that approach. So these slides are a little weird versus what I see on the screen, but so if you can't read it, my apologies. I think they are going to provide these out later as well. So what we're going to talk about today is some of the challenges that you see with AI trying to keep up to speed. And then I really wish this didn't cut off, but I will explain it. The process right now, when you're working in AI to build a product, or in this case, to build a talk, is that you find a new cool technology for AI, and then you build a product, or a talk, or something. And you're working on it for a little bit, and then, oh wait, another cool technology came out. Let me go update that and get it into my product, and we'll start working that and all this kind of stuff, or get it into my talk. And that's great. And then you start working to get that built and finished, and oh wait, another cool technology just came out. They updated this thing. Now there's a new model that does this. And then you iterate that. You jump back to, okay, I got a new technology, get it in, work on it or whatnot. And then if you keep doing that long enough, you will find that some big model just dropped, and now it's in everybody else's product for free already. That to say, there's been several things. If you go back, and it's kind of funny, if you go back and look at our GitHub group, and you drop back into like 2018, 2019 timeframe, one of the things we were working with was a bug analysis program. So you've got things like the Linux Foundation, the Eclipse Foundation, the Apache Foundation, all of their software repos, all of the source code. If you were to actually count how many people are committing on those projects, yeah, it's a very, very small number per the, based compared to the size of the code. So what we were trying to do was find ways that if you're a committer, if you're working on a bug, let me recommend some other bugs to you that might be in the same thing that you're working on right now. Eclipse Foundation at one point when we were tracking it had 140 million lines of code and 1,500 committers. So you had 1,500 people doing 140 million lines of code. I mean, that's not out of the ordinary. So we were trying to find ways to do that. At the time, we were using just basically term frequency, inverse document frequency kind of approaches, all probabilistic. We moved from there. The glove paper dropped. We started doing embeddings, and that was fun. So we dropped the TD-IDF thing. We're now doing, embeddings per word, and then this whole doc2vec thing dropped, and we're using a GenSim, paper like that, doing document vectors and such. And it started incrementally getting more. And then as the large language models dropped, you could fit nearly everything into the context window of some of these. I don't even have to embed anything anymore. Most of what I had been working for the previous 4 years as a little side project, I don't even need to do that anymore. That's common in AI. It was 2023. I was doing a talk at the SMD Symposium. They had the small business, kind of a thing where you get up and you talk about what your small business does. So from Cohesion Force, I'm the CTO there, so I'm up talking about everybody wants the big models because ChatGPT had dropped the previous November. It's a big model, everybody wants it. So we basically came up and said, hey, everybody wants this. That's great. They're not going to give it to you, by the way. And even if you did have it, here's the cost of the servers it would take to run it for you. You know what I mean? So the best thing you can do is to take a small model, fine-tune it for your benefit, and then go that route. And so I'm getting ready to talk at an SMD Symposium in August. Anybody know what dropped July? I think it was 16th or late July that same year, 2023. Llama 2, open source model. Right here, everybody free to use. So the whole thing, I had built slides and gotten ready to talk about and gotten things released so I could talk about them and whatnot. I'm about to get up and talk. Everything I'm about to say is now invalid. So it's fun. I am fairly certain there's some people maybe in this room that had a good presentation up until DeepSeek dropped last week. I mean, this is normal. So the whole point is to start getting ready to work with this new normal if you want to be involved with it. So the whole thought is continuous learning. So the main thing is to look at where are things moving? How fast are things moving? If I am brand new trying to get involved, where do I get involved? If I'm working on a product, what do I need to be watching out for? Where's the movement coming in? So one of the primary sources that I use is a Stanford 2024 AI Index. This dropped February of last year. There should be a 2025 coming out next month. I did take it and shove it up into ChatGPT because it's over 500 pages of graphs and documentation, market surveys, everything into investment, to technical papers being dropped, to conference attendance, to things like that. So I use that a lot. Normally we'll do like a session at Huntsville AI to kind of cover it because it is very interesting from a market survey perspective. And then Hugging Face actually has stats. I didn't know it until I was putting together this paper. So they actually have some live notebooks that you can refresh over time, and it'll actually show you how many models have been uploaded. How many data sets have been uploaded, how many are coming out per month, things like that, just to kind of give you an idea of what's going on. So published papers. And this has been since the 2016 time frame. This 2015, 2016, that's around the time where you got some RNNs and things like that started to come up, and then you had transformers pop, and then you had large language models start to come in, and you start to see a we were scared when we were about right here because looked like it was just going to keep climbing and climbing and climbing. Last year, it actually started to settle a little bit. I'm still waiting to see 2025 what they say. We've run into a similar thing. Actually, this is totally different. This one is this is the one that hasn't plateaued yet. This is actually the number of patents, and this is worldwide. And so this one is kind of interesting because some countries do patents a little different than other countries and such. I'm not quite sure how this is going to interact with the open nature of AI as it's been going. Because one of the ways to avoid patents that you may, run into or something is to not share how you do things, which would actually hurt what we're doing. Looking at private investment, this was another one that there was a giant jump in 2021 that then kind of went back down. But don't worry, Gen AI is going to save us. So this one actually, everything kind of went towards the Gen AI. I kind of expect that to possibly, keep rolling in that direction. I'm interested to see where it goes from there. I don't know if it'll be Gen AI or Agentic AI, and I wish the two words were a little different in how they sound. Models. That actually didn't even show up. So if I go back quick, if this did show up, you would actually see it go up and actually start to almost flatline. Hugging Face actually hit over 1 million models hosted at Hugging Face. I think it was September of last year. And then it actually started to plateau. It almost looks like a flat line, but the data there isn't a flat line, so I know it's not just some kind of a data pool issue. But then looking through some possible entry points. So thinking through, so there's a lot of movement. There's a lot of papers being published. There's funding coming from all over the place, private funding, government funding, things like that. Looking at if you are a technical-minded person, maybe you're a software engineer, maybe you're a computer scientist, or working in some kind of a field, one of the ways to think about where do I enter this whole thing is from the technical perspective. So you've got things like natural language processing, can I classify text? Can I do sentiment analysis? Can I tell if this post is angry or not? Can I tell if these two things are similar? Can I tell if these posts were generated or not generated? Can I tell, it's a very wide field. That's one thing. If you really are into language, that's a place. Computer vision, looking at things and saying, hey, is this a cat or not a cat? Or a hot dog or not a hot dog in some cases. You should look that up if you're not familiar with that reference. So there's segmentation, figuring out what parts of an image go with what. enhancement, generation. Most of these items have a generation piece at the end of them due to the Gen AI piece. Audio processing, recognizing whether it's me talking or somebody else talking, transcribing speech. There was a competition we had entered, I think it was 2 years ago, to take a big, basically taking sound files and splitting them up into their subcomponents. I need the vocals, the drums, the keyboard, and anything else. Multimodal tasks. This is one that's been popping pretty well recently. Being able to work with both images and text and sound or video, things like that, all in one big box. That's been some of the interesting stuff that, the last presentation where you saw where there were images that were being used to actually influence the generation of a video. Pulling colors from this, things like that. That's a place to get involved or to learn. Reinforcement learning. A lot of people think this is more robotics, of how does a robot learn its way around a room and how to pick stuff up. But it's also very important in some optimization tasks. If you're thinking about, hey, what's the best way to route a car to get places? What's the best way for FedEx to go pack all of their stuff into one tiny little thing that they're going to shove on an airplane? How do they make sure they get the most stuff on there that can fit? Recommendation systems. Everybody deals with this nearly, every minute of the day. Every time you open your phone and you look at a social media feed, if you're using free email systems, they will provide ads or something like that. All of that underneath is recommendation systems. Something has to recommend the thing that you're probably going to interact with. Generative AI, text, images, audio, video, all of those fun things. And then explainable. I'm pretty sure you're going to get into some of that next, but I knew that Dr. Monroe was going to be following me, so I made sure and we get some explainable. I'm not super familiar with that. That's basically figuring out why a model's doing what it's doing, and so that you can actually build trust in it. Agentic AI. I think this might be called the year of agentic AI. So tool calling, decision making, things like that. How do I make my own agent? There's a commercial on right now for Salesforce or whatever they're calling their new thing with restaurants. And how do I make sure I get the right schedule? How do I make sure this person knows how I know what they like to eat? Things like that. Embodied AI, humanoid robots, autonomous drones. It's some pretty interesting stuff going on there. So if you like robotics, that might be a good place to enter. The other type of thing to think about, if you're maybe not a technically minded if you're not into the, computer programming or, things like that, another place that you can get involved is on the, think of it coming in from your use case. If you're a healthcare professional, there are things that you know about healthcare that the folks that might be building some of these models might be missing. This is why we need as many different kinds of perspectives and people involved, because you've got sometimes a gap between the technical side and the use case side. So getting all of these people in the same place. So 10 of the top areas, according to ChatGPT, and the paper that I fed it, healthcare, medical image, drug discovery, health assistance, finance and insurance. Do we make a loan or not a loan? Risk assessment, fraud detection, agentic. Automatic trading. That's been there for a while. That's actually a pretty interesting thing. Retail. Dynamic pricing. This came up at a talk I was doing last week, which we'll get to again in a minute. About, hey, if I log on to an airline and I'm trying to buy a ticket and I'm just wanting to see what flights are available, and I happen to notice the prices, and I come back and I log in again the next day to see, okay, now I want to buy that. Guess what? The price is probably different than it was the first time you looked. They know you're interested in a trip. They know that you're interested enough to come back. They know that you're likely to pay because they've already shown you a price and you're back. So anyway, that's a lot of the retail side of that. Manufacturing, predictive maintenance, logistics, things like that. How many parts do we need to keep on hand? I mean, there's a lot of stuff there. Energy, with forecasting, efficiency, monitoring. It's odd that AI is now probably one of the largest consumers of energy at this point, and we'll wind up using the AI that's consuming the energy to figure out how to optimize the energy that we're getting. Entertainment. I'm going to skip entertainment. Agriculture. This is one that's been very interesting, and as somebody that grew up surrounded by cotton farms in Mississippi, I remember when it used to take 20 people and several pieces of equipment to pick a cotton field. As a kid, I got to help do some things that now as a person sitting, in a cotton picker while it drives, bales its own cotton, drops it for later. So there's a lot going on with like yield optimization. There's a lot of there's some folks that are working with drones and doing image recognition flyovers to find spots in fields that need more water, things like that. Security, surveillance, intrusion detection, autonomous drones, things like that. I remember we did, and playing back into AI is always changing. They did to get onto the arsenal, there is a lane, maybe 2 lanes now, that use facial recognition to let you through. There's still a guard there, and it takes your picture, and it tells the guard, whether yes or no, or hey, check this guy's ID or something. But for the most part, you just slide you right on through. They do have you actually have to have a card to get on, so they have a pretty good picture. It's kind of odd that it works through a windshield. It works even if you're wearing sunglasses. At the time, we did a session at Huntsville AI to talk about the bias that's in these data sets that's used. Before that, state of the art, if you are an average white male, looks like me, accuracy was in the mid 90%. If you are an African American female, the accuracy was high 60s, low 70s. So not only was there a 70% chance that this person was going to make it through, if you stop them, you're impacting their life. They may miss a meeting and all. The opposite side of that is you got a 30% chance of letting somebody through that shouldn't be here. Speaking of changes in AI, since then, those numbers we took another look. Those numbers are way, way, way more high, technical talk, and fairly even across that. So if you're like me and you've been talking about this, go back and look again, because it's changed. It's probably also why you saw some of the tech leaders like IBM. There was actually a recognition module that was in Amazon, AWS. We actually did some talks on that. Some of those have actually not been, they're not pushing those anymore because it's easy now. And the accuracy level's gone up. And then space, hello NASA. There's actually a kind of a companion app that they've got that's kind of neat. And then if you go over to the museum and you see the rover thing they've got now, that's pretty neat. Talking about autonomous. So I'm hoping the grid actually shows up. It's showing on this screen, so we'll see. So this is something that I brought from my CTO technical background into my AI background and kind of mix the two. So if you're familiar with NASA work, you have heard of what is the TRL of this or that or whatnot. It's a little confusing because other organizations also have a TRL that's loosely based around NASA's TRL, but we had to change some words because I don't know. So I normally stick with NASA's. It kind of shows you what level of maturity this thing is. Has anybody tried it? Has more than one person tried it? Is it actually fielded somewhere? If you're looking at working with some company or their product, how many users do they have? Things like that. And then churn is a totally made up term. it felt better than instability. So what we're looking at there is how often are updates coming in the field. So what, in other words, the more papers you see drop for a particular area, the higher the churn is what we're talking about. So anyway, if you plot this on a graph, usually I use this for a lot of things, and typically my rule is I will set the grid here such that it forces a prioritization decision to be made. So if we're looking at maybe the impact and the cost, if the cost is low, impact is high, I want those. If the impact is low and the cost is high, we get everything plotted on the grid. I actually just throw away a whole quad. We don't even look at it anymore. So that's fun. So we're going to talk about the 4 quads. I've actually given them names, which is, I guess, my prerogative because I made it up. So safe place. Everything in this quad is mature. There's a lot of people using it. The use cases are well known. If you're doing it right, which is kind of odd sometimes to think that sometimes we're doing things we're not even sure if it's right or not. Users know what to expect out of this. I'm not sure the first time any of you kind of ran into ChatGPT, but it was a little odd at first. Like, what do I do with this? Do I type questions? Do I tell it what to do? Do I tell it what I want? Things like that. If you're new and getting started, this is probably a good place to be for a minute. Get your feet wet, learn some things, especially if you don't have time for the continuous learning. Quad 2, I'm calling this Adventureland. This is where most of your AI practitioners live. It's fun. There's a lot of people here. There's a lot of papers here. You know what I mean? It's a pretty good place. Things change, usually iteratively. You may learn something and then something else will come up, and maybe you don't do it exactly the same way, but maybe some of the parameters changed. Or if you're working with an LLM, maybe the context length changed. Or, so small incremental. Sometimes you got to be aware, though, because every once in a while, something will come along and we'll take what you're doing here and we'll move it right back down to here, which we'll get to in a minute, kind of like the DeepSeek model just did. You probably have a lot of people that were out buying a lot of hardware, and now they're asking, do I still need this hardware, or do I need a smaller hardware? Or if I did have more hardware, can I run more things on it? Those are conversations happening. Quad 3, Frontier. This is cutting edge stuff. This is a lonely place, by the way. You're dealing with stuff that Google is not going to help you. You're going to put stuff into a Google search or whatever search, and you are far enough on the front edge, which I've done this one time where I put in a Google search and it referenced to something I wrote the year before. And it was this not helpful. So this is a figure it out yourself kind of place. It's kind of wild. High research paper consumption. I've got Josh in the back of the room, who is my chief data officer, does a lot of paper munging, I guess would be the good word there. So if you are interested in this kind of thing, it's going to take a good bit of time to keep up with what's going on. The other side of this, why are you here? This is the immature stuff. This is the boneyard, the desert. I liked it as the land of discarded models, things somebody tried once and that may or may not have worked, but they still felt the need to post it. It could be called the pit of despair, depending on your movie reference of choice. And one thing I'd say out of here, it's okay to visit the boneyard. You just don't want to be there for an extended period of time unless you have some plan to either move into another. As a reference, last year we spent most of our time, we spent probably a couple of months worth of a series at Huntsville AI talking about how to build a RAG-based system to do retrieval of and inspection and questions and answers based on the large set of documentation that NASA actually has. So we spent a lot of time there. The actual RAG paper, the main one, was actually released in 2020. So some of this was kind of in this realm for a little bit. The actual model, the actual paper was written, the LLM it was using was BART Large at the time. It had a whopping 400 million parameters. To give you most of our small models now that we use have a 3 billion parameter. I mean, that's kind of the floor. Some smaller, but so it had 400 billion parameters in the model it was using with a context window by default of 1,048 tokens. We are nowhere close to that small size now. So it could have been, and I'm just guessing, that it kind of hung around in these lower areas until finally something dropped. Now I've got actual LLMs with enough power to take the RAG, or to take the actual pieces that were pulled from a semantic search. Now I have the context window to actually make it more useful. So don't be too afraid down here, but it's also maybe not a place that you want to hang out forever. So I took the technologies on the grid, put them up here. So I don't know how it did this, but explainable AI it put dead center, which was fun. And again, this is notional. This was me taking the paper or the Stanford index and saying, hey, based on this index and the information you see here, where would you plot these technologies on a graph of churn versus maturity? And even the graph is 100% out of GPT, Chat GPT. It did give me the Python code to recreate it myself, which was kind of neat. So some of the things, NLP, pretty well known, used a lot. Recommendation systems. Those have been around since you pulled up to a drive-through window and were asked if you would like fries with that. So there's that. Generative AI is kind of up here. This thing changes so often. Some of the early things, we're still agentic AI. We're still trying to kind of figure out what that means and how it can be used, how many different places it can go in. If I flip over to the use cases, I got things like space and climate modeling, and quantum computing is fairly new to a lot of us. The thing about finance, we've been doing finance for a long time. AI has been involved in finance and insurance for a long time. Retail, healthcare, agriculture, transportation, stuff like this is about mid-range. So, learning approaches. First off, you got to know yourself. And this is kind of tuned to folks that may want to get, maybe coming to a conference is a great place. This is 3 days out of the whole year that you're probably going to spend trying to get into this. From what I've found, and I actually need to classify this 2 different ways. Most people learn in 2 fairly different kind of approaches. Some of us like to go to a course and have somebody that is more of authoritative, that an expert in the field actually walk us through how to do things. This is typically your coursework, and there's not, and I don't mean you have to go to college for it. There's a lot of coursework online. Some of the, if you want a good NLP course, Stanford Lectures, YouTube. Go find Christopher Manning's lectures. Walk through that. Others, and this is where I live, is mostly in the, let me get my hands on it, let me play with it, and I'll find out what it can do, and I'll find out what it can't do. And each one of these is valid, and there's ways to do it, but they don't all work for everybody. The other thing I've noticed is some people like learning with groups of people. So I need people along with me. Others are kind of lone rangers. Let me go. I'm just going to go do it and learn it myself. So some practical tips. Learn AI. Use AI to learn AI. Be aware that it does sometimes give you bad information. Check your references. You'll hear that a couple of times. Join a learning cohort. Some of these online classes actually have pretty good web forums and things. So they'll start off a course, maybe Coursera or Udemy or something like that, and you're learning along. There's typically a forum of some kind that goes with the class where you can actually interact with some other people that are going through the class at the same time. That's useful. Newsletters. TLDR is one of my favorite lately. One thing to notice on newsletters and things like that, a lot of times they're sponsored. They should tell you that I'm sponsored and here this is a sponsored thing, and then here's the other information. If they're trying to sell you something, you're probably in the wrong place. If they try to sell you too hard on something. Podcasts, this is my favorite way to learn. I will pop these in while I'm driving or whatnot. You got Gradient Descent, that's a great one. TWIML, which is This Week in Machine Learning. Sam Charrington has been running that one for about as long as I've been doing Huntsville AI. Data Skeptic, and then Last Week in AI. The Last Week in AI is about an hour and a half long. I mean, they cover a lot of material. Join or start a local group of AI enthusiasts. I just want to throw that out there since I do run one. Caveat, check your sources. It is possible these days to use ChatGPT or some other kind of generative approach to spin up LinkedIn pages. You can spin up websites. You can put whatever name you want on them, and you can actually get people to follow you. So there's that. Believe it or not, we actually had somebody last year pop up in April and attempt to trademark the name Huntsville AI. Which was interesting because we've been running this group since 2018. The trademark actually got rejected, but it did not stop them from producing their own newsletter, having their own website, having a set of LinkedIn pages, calling themselves Huntsville AI. So beware. If you are trying to find us, it's hsv.ai. So there's that. So again, check your references, check my references. And then another approach is to start with a framework. Some of these that you see from a computer science or a programming background, TensorFlow, PyTorch, a lot of these have a lot of tutorials and walkthroughs. Hugging Face is a good place to start with that, and things like that. The caveat there: learn the concepts of how they work and why they're doing the things they do, and not specifically how this tool does it. Otherwise, you're kind of locked in, and if something pops up somewhere else and you need to move off of that, it might take you a minute. And with that, I think I'm close. So do we have any time for questions, or we do? Okay. Any questions? Yes.
Excellent talk again, and thank you for organizing a good bit of resources for the community. I was wondering if you had considered organoid AIs and how that's going to change the energy sector and how we do quantum computing and analysis going forward in AI.
What was the kind of AIs?
Organoid AI. That's basically brain cells in a Petri dish, and you hook things, and it's bringing back the good old Hollywood sci-fi back. And
interesting. Back to where it started.
Exactly, because LLMs have a lot of energy consumption, so let's bring the focus back to human brains and put them in a Petri dish and connect electrodes. So what do you think about that in ethics?
I think it's a very interesting thing. I would lean towards somebody that had a large background in trustworthiness in AI. To know whether or not I needed to, and that's a play. If you didn't see their session the other day, it was great on that. So what I'm thinking of is if you're looking at something like other cells connecting with AI and actually using the biological approach to have, most of AI these days, neural nets actually were based on what we thought the human brain worked, how the human brain worked back in the 50s, 60s, and whatnot. I could see that actually being, maybe you, instead of building a neural net, you build it out of cells. And it'd be much more efficient. I'm not quite sure where that goes. I think right now they're more you're seeing things trying to figure out how do I use AI to actually augment a person. Let's say someone that has, maybe a hearing problem, or things like that. How do I actually tie into the signals that are going on in somebody's brain to actually activate some kind of a mechanism? But I don't know that I've seen anything looking at how do I take a different type of organism and tie into that. But that is pretty interesting.
I'm William Monroe. I work at Analytical AI. We also have a joint venture with a company here in Huntsville, OSS, Offset Strategic Services, if you're familiar with them. And that joint venture is Strategic AI Services. And in both places, really what we're doing is we're using AI to make the world a safer place. So the name for my talk today is Who Said That? Explainable AI for the human in the loop when lives are on the line. A lot of the applications where I'm working, the consequence of a false alarm isn't an oopsie. And so if the consequence for a false alarm or a hallucination isn't an oopsie, then what do you do? So just a little bit of background about where I'm coming from. Analytical AI is a company in Birmingham, Alabama. We initially started out doing medical domain AI, and then moved into doing security AI as we had some success with things like TSA put out a passenger screening algorithm challenge, and some of the co-founders came in and actually achieved the selected solution from TSA. So we continue to work with TSA on that algorithm. And then more recently, we've started this joint venture, Strategic AI Services, up here in Huntsville, focused on the DoD customer. And I tell you these things not because I'm hoping that you're going to work with us necessarily, but just because I want you to know when I say when lives are on the line, the applications that we're working on are things where lives are on the line. All right, so my graph isn't as complete date-wise as Jay's was, so it was nice to see his graphs and see that these trends continued. But this is a graph of papers in neural networks and artificial intelligence, specifically in the medical domain, and then the blue line is NVIDIA's stock price. So the key takeaway here is that as the research has continued, as AI gets more complex, the investment in the hardware and in the support that you need to deploy these models also continues. And as we saw from Jay's graph in his talk, these trends have only continued. It did not stop here. All right, so back a little bit to some of the applications. I'm not going to go through all of these applications, but just again to reiterate what I mean when I say AI where lives are on the line. So like I said, I've started doing, and in my intro you heard, doing medical imaging, so pulmonary imaging, finding the lungs and lobes, COPD in the chest, things like that. And then now what I do is focused in these sorts of domains, things like soft targets. If we can identify an abandoned bag in a public place so that somebody can go investigate that and resolve that potential threat before it becomes an incident, then that's a great thing. If we can use AI to detect foreign object debris on a runway before a plane takes off and runs into it or sucks it up into an engine and it causes damage and potential harm, all the better. So these are all spaces that we play in. So there are a lot of things on that slide. We call it the spider slide because it has the kind of web-like nature to it. But really, if I needed to boil it down, if you said, what if I could boil it down into one sentence, what would I say? And it's this one right here, that if a human can see it, we can train an AI model to detect it. And so in Jay's graph of all of the different domains, we fit pretty tightly in the computer vision domain. And we focus on making this multimodal, high trust, explainable, and deployable AI. The key thing is that it's not good enough when you're in a high trust situation to have a model that works. You need to know why it works. So it's awfully funny to put a picture into ChatGPT, say, what's this, and have it totally flub. But when you're in one of those scenarios, a security-based situation, if it does that, that's a real problem. Real Housewives of Atlanta is the closest Real Housewives franchise to Huntsville, I believe. So that we're going to use them. We talk a lot in AI and technology about what the technology can do. And so it's awfully funny. I think if you counted by word, I think the phrase "who said that" is probably one of the most utilized phrases in reality television, because we really do care where the source of the information comes from, and that gives us as humans a context for what does that mean, can I trust the information and all that, right? And so the problem is that by and large, AI is black boxes. So we call it AI because it's easier to say artificial intelligence than it is to say massively piecewise linear regression. And it's easier for us to interact with it by anthropomorphizing it than it is for us to think about all of the individual nodes in there. So even if the model that you're using is not technically a black box, I would posit that if you can't just open it up and look inside and it can tell you what it's doing, it's a black box, right? If the math is complex enough that I can't explain it to my 6-year-old, it's a black box. And so this is really where most of our models live, is in this realm of black boxes. I put something in, it goes through, I know that notionally on the back end there's a bunch of layers, and then at the end I get an answer. Is it a dog? Is it a cat? Is it both? Right? And for this example, if it messes up and it says there's only a dog in there or only a cat in there, or it says it's a horse, big deal, right? But now suddenly I'm in this space. All right, and this is where I did some of my PhD work, was in the brain space, and I've got another example I'll show you in a little bit with the explainable AI piece. But when I'm giving these images to a neural network and then asking it to do some type of diagnosis, suddenly the consequences of getting a right or a wrong answer are really big. And that's where I think we don't, as a community, spend enough time thinking about the consequences of our actions and the consequences of the AI's decisions. As an AI developer, if I have something and I say it detects 99% of the tumors, always, if I don't also tell you, oh yeah, it's got a 50% false alarm rate. Okay. Well, if I tell somebody they have a tumor and they don't have a tumor, that is also a life-changing event. They might end up getting chemo, which is very harmful to them, and something that they do not need to do. In this particular model, if I tell a doctor that this patient has a stroke and they have a hemorrhage, suddenly they get a medicine that's going to kill them instead of a medicine that's going to save their lives. And so who said that, why it said that, is suddenly really, really important. And it's something that just constantly needs to be in the background of our minds as we're looking at all of these AI models. All right, so there's a few things going on in here. We'll take them one by one. All right, so first, there's a paper in the tiny little text that you can't read here. It was from a Google researcher from 2014, and at that time he called machine learning the high interest credit card of technical debt. So technical debt is a concept that I can use a piece of technology without understanding it. Kind of similar to like if I'm playing music and I just go and I find some guitar tabs and I learn a particular run on the guitar and I don't realize that that's a C scale, but I know how to play it and I can play it and it sounds good, but I don't know it's a C scale, then that's of limited use to me. So similarly, with machine learning, it's really easy to put a whole bunch of stuff into a model, get results out of it, and declare victory without knowing why it's doing that. And that can be a problem, as you can imagine. As in the previous example, if I'm telling somebody they have a tumor and I don't know why I'm telling them they have a tumor, that's bad news for everybody. This second piece, which again, this is in the tiny paper citation you can't read, is from a medical paper from 2017. They did a study with computer-aided diagnostic tools, and they found that when they intentionally gave the medical residents bad data, when they intentionally gave the medical residents bad information from the computer-aided diagnostic tools, their diagnosis ability decreased by about 10%. So suddenly, if I give everybody in my organization ChatGPT, and ChatGPT is telling them the wrong way to optimize their Python code, they're probably going to believe it. And we're probably all going to have slower code because we believed it without checking. And so that's where the previous talk, and I'm sure you've heard that, you need to check your sources. That's a big deal, especially as we move into higher and higher trust situations. I really appreciated the drone talk this morning about using drones in law enforcement. It becomes really important when you're in that scenario to check what the AI is telling you. So really, how can we trust the AI when lives are on the line? And really, it all boils down to this final point, which is don't expect what you don't inspect. So I know this is kind of an old motivational speaker line, but I think it comes in really handy when we're talking about artificial intelligence. Just because it's giving us answers doesn't mean that we're suddenly relieved of the responsibility as the humans to go back and check why it said that. All right. So this is another common thing that I feel like I see is that we as engineers train the AI to be human-like, and then the AI is human-like, and then we start to believe that the AI is human-like. But really, when it all boils down to it, does the AI have any context? Does it have any motivation? And what I would argue is that all that the AI has is a metric. The AI does, the AI that I showed earlier about the tumors, it doesn't care if somebody has a tumor. It cares if I give it the right zeros and ones as a Scooby snack. And in every application that you use AI, that AI is only concerned about optimizing its metric. Concerned is the wrong word because it doesn't have any feelings. But this also works for things like chatbots. You get more out of chatbots for a marketing platform, for like a Salesforce thing, by being polite to it, not because the AI cares that you are polite to it, but because the AI was trained with data of conversations where polite people got more out of the sales representative. And so those are things that we bear in mind. It's important to be nice to the AI, not because the AI overlords will remember us someday. It's important to be nice to AI because that's the data it was trained with, and if you want to get a refund for the pants that you got for Christmas that you didn't send back in the right time window, be polite to the chatbot, and it will probably work out for you better. So to illustrate that, I have some human examples where humans are overly focused on the metric. Okay, so what do license plates and pest control have in common? And really, these are two human scenarios where, as humans, when we're overly focused on the metric, we lose sight of the reason why that metric is there in the first place. There was an instance where they did license plate rationing in Bogota, Colombia. So they said, hey, we've got a lot of pollution, we got a lot of traffic, I know what we'll do. If you have a license plate that ends in an odd number, you can drive on odd days. And if you have a license plate that ends in even numbers, you can drive on even days. Suddenly, we've cut half the traffic. Boom, problem solved. Except, why don't I just buy a second car, hope that I get a license plate with the other number, and then suddenly I've got two cars, twice the waste probably, and then we'll just not have less traffic. Now everybody in the house has two cars, so a two-person household may have 4 cars instead of 2. So it kind of backfires sometimes when we get overly focused on the metric. And so it's not just AI that does this, people do this too. The other thing is there's all sorts of instances where this has happened in Mississippi, in India, in anywhere that you can think of. They've said, hey, we'll pay people if they'll bring in a cobra head or a rat tail or a pigtail, because these things are tearing up and destroying property, they're dangerous. Well, if you tell me that you're going to pay me $100 for every pigtail I come in, suddenly I'm a pig farmer, right? And the AI is even more susceptible to this because it doesn't have any sort of sense of ethics or anything like that. So this is some images from one of our applications where we're doing situational awareness for the Army. And I highlight this because humans in the loop are vital for those instances where the cost of a false alarm is too high. So with our work with TSA, we work on the next generation algorithms for the next generation on-person screening technology. So you go through the airport, if you assent to be screened by the HDAIT scanner, that's the one where you stand up with your arms like this, and it spins around and it takes your scan. First of all, it's very good for everybody here and everybody everywhere that Congress has said that they only get to look at avatars and not your actual image from that screener, because it is like Superman X-ray vision and it sees way more than you want it to, and your doctor could probably diagnose certain medical conditions based on just that scan. So that part's scary, but the nice thing is there are regulations in place. Nobody gets to see those images, so we can take a breath. But because of that, because they look at a stick figure, they don't look at your image, we have to have algorithms to tell us what's on you and if you're carrying something you shouldn't carry. Now, if I do a false alarm there, what's the worst thing that's going to happen? I'm going to get groped by a stranger. I know that's a crass way of putting it, but that's the worst thing that's going to happen, is that they're going to say, excuse me, sir, we need to see you over here. And then they're going to feel my shoulder or wherever the false alarm was. And then they'll say, well, do you have a pin in your shoulder? And I'll go, yeah, I might have a pin on my shoulder. And then they go, okay. And they let me go, right? It's uncomfortable. It's inconvenient. But at the end of the day, it's not that big of a deal. In this situation, if I'm giving situational awareness algorithms to the Army and I get a false alarm and I tell them that you have a gun on you when you don't, I don't think you're coming back from that. And so in these situations where the cost of a false alarm is life or death, it's really important to get it right. And it's really important that humans are in the loop. Because AI can't take responsibility. At the end of the day, the AI can't even say sorry. I mean, I guess now it can, but only if we ask it to. AI even thought that the bear was the right figure for this slide because it could not contextualize that I was saying who shoulders the weight of the responsibility. I typed this in and then Microsoft Designer said, oh, I know what you need on this slide. You need a bear. So I went with it. So now we get into the fun nitty-gritty technical stuff. And I'll resolve with a not-so-gritty version of the technical algorithm that you can use today with things that you have on your person. All right, so there's a whole bunch of class of algorithms called explainability algorithms. This particular one is called GradCam, short for gradient class activation mapping. This is used for image processing algorithms to tell you whether or not the features or where the AI algorithm was looking when it made the decision that it made. So if it says there's a bull mastiff in this image, give me the feature importance map, and suddenly I get that nice little heat map and I go, oh, nice. The algorithm was looking at the dog when it said there was a dog in the picture. That's great. That's what I want to see. And so we can use these sorts of algorithms to do all sorts of stuff. So here's a figure from my PhD. And this is a brainstem for those of us that, I mean, it really could be anything, but it's a brainstem, so you'll have to trust me on that one. And one of the researchers I was working with during the PhD, he would do these great statistical maps where he would look at a whole bunch of different brains that had a diagnosis like Parkinson's disease. And then he would do statistical methods to find which areas of the brain were affected by Parkinson's disease. And so he has this map of the brainstem, and this is his statistical heat map using everything that he knows as a neurologist about where the important regions are in the brain for Parkinson's disease, and specifically in the brainstem. Now, when I use that same gradient class activation mapping on a neural network trained on this data, half of the regions that it thought were important are outside the brain. Now, that's weird until you realize that in order to get all of these things lined up in the same space, I have to do some image transformation, some Fourier transforms, and there's a gradient field outside the brain related to the spatial positioning of the person inside the scanner. It's likely that what's going on here is that the AI model is picking up on one of two things. Random JPEG noise that it was able to say differentiated the two classes, or actual Fourier transform noise due to the person's head being cocked a little bit to the side, because folks with Parkinson's disease tend to have a hard time having their heads straight up and down. And so when they go in the scanner, you're going to see a standard difference in the space around the brain due to those transformations. All that to say, AI is lazy. So it's just looking for that metric, and if it finds a shortcut to get there, it's going to do that. And so you really, all it's going to do is look for that least resistance path from it to that metric. If you feed it a bunch of images of cats and dogs, and all the dogs are on grass, and all the cats are on something else, it's going to learn what grass looks like. It's not going to learn what dogs look like. We've experienced this with some of our models where it absolutely learns the background rather than the item that we're looking at. All right, so now the real practical bit. So there are other versions of explainability called occlusion sensitivity. The standard way you do this is you basically black out a subregion of the image and you move that in a pattern over the image. You do it if you have a 256 by 256 image, you do it about 50,000 times at each pixel location so that you get a nice round feature importance map. My PhD results were more of an emperor has no clothes version of that, where we're not interested in pixel level features. We're generally interested in hierarchical feature sets. So if I can black out half the image and then suddenly the AI doesn't know what I'm looking at, process of elimination, that was the important bit. All right? So everybody got a schedule today, right? If you wanted to figure out what ChatGPT was looking at in a picture, all you would need to do was take that picture again, cover up half of it, and then send it through ChatGPT again. And if it suddenly doesn't know what that's a picture of, that was the important bit. If it still knows what it's a picture of, and you covered up the important part so a human wouldn't know what it is, then it's retaining some kind of information that you're not aware of, or maybe that information is in its training data somewhere. All right? So the way this flowchart works is you can take if you want to do this manually, you can. You can just cover up a single part of an image that you want to feed through an image processing algorithm, and then you can send it through your AI model and then see how it changes the results. Okay? And so all I've done here is if you do it systematically, you go top to bottom and then left to right and send it through. Then if you're handy with Python, and everybody is these days because ChatGPT helps with that, then you can turn that into a heat map, and then you can just see where the important features are based on the original image and just blacking out some regions. Great thing about this versus that GradCam is this is a truly black box method. So we could do this to ChatGPT. I can do this to my 6-year-old. He's learning how to read. And so I can take a book and I can cover up half the page. And if he still knows what the words are on the page, then I know he's memorized the words, right? And so this is an explainability technique that you guys can take with you today. All you need is a sheet of paper or a cropping tool in PowerPoint, and then you can use this. And so with that, I'm going to conclude with just these 3 points, okay? When you're dealing with AI, and really anything, but AI is the topic of the day, you want to inspect what you expect, all right? You can't say that you're going to be treating tumors and then expect the AI is just going to do what you want it to do and assume that it's going to look at the right part of the brain, because it may look at something else. It may decide that it's easier to say that somebody's sick because they got a scan in the emergency room than they got their scan in the research scanner. Also something we've seen in our research before. AI can and should be explainable. If somebody says, other people are black boxes, we just need to get over it and just let our AI be black boxes, just back away slowly, find somebody else to talk to. And humans in the loop really are necessary where responsibility is required, because the AI only cares about the metric, so that's all it's got. That's all it's got.